This video is going to go over 4 of the most missed questions that was on Unit 3 test. The first one I want to go over is finding the Taylor polynomial of order 3. First thing to remember is that when we're looking for the Taylor polynomial, we're looking for the partial sum when k is equal to 0 until we get to whatever order we want, in our case 3. We're going to find f in the derivative to whatever value of k. So first derivative, second derivative, third derivative. And then we're going to plug in our value of 5. We're going to have the binomial of x minus a, in our case 5, to the k power. And we're going to divide that by k factorial. So what we notice when we plug in k is equal to 0, so I'm going to put my values for k here. When we plug in k is equal to 0, we're going to go find f of k at 5. So first thing we're going to do is find out that this is f of 0, which means we're not taking the derivative. So we're just looking for the value of f at 5. Then we're going to let k is equal to 1, so we're going to go find the first derivative when it's equal to 5. Well, what we have is that f is equal to natural log of x. So f prime is equal to 1 over x. So that means I'm going to find this to be 1 over 5. This one up here we found to be the natural log of 5. So when k is equal to 2, we're looking for f with the second derivative, and then we're going to plug in 5. So the second derivative is the derivative of this first derivative. So when we take the derivative, I get negative 1 to the x to the negative 2, which is the same thing as negative 1 over x squared. When I plug in 5, I'm going to get negative 1 over 25. The last one we need to do is when k is equal to 3. That means I need to go find the third derivative and then plug in 5. So the third derivative is going to equal to a positive 2 x to the negative 3. Or 2 over x cubed. When I plug in 5, I'm going to get 2 over 125. So now I have found all of these guys in terms of my equation. I have found all of these terms. They're right here. And so this one's pretty easy. All I'm going to do is plug in k, change the value of k, and we're going to have x minus 5 to the 0 power, to the 1 power, to the 2 power, and to the 3 power. And then from here, we're just going to plug in the values for k. So let's do that. So here we go. We're going to start off with k is equal to 0. That means I'm going to use this value, natural log of 5. And then I'm going to have this guy to the 0 power. Well, anything to the 0 power is 1, so I'm not going to worry about that. And down here, I'm going to have 0 factorial. And that's also equal to 1. So we're done with this term. When k is equal to 1, I'm going to find this term, 1/5. I'm going to use my binomial to the 1 power, so it's going to be x minus 5 to the 1 power. Down here, I'm going to have 1 factorial, and that's equal to 1. So that's my second term. Plus, now I'm going to let k is equal to 2. So it's going to give me negative 1 over 25. I'm going to come up here and I'm going to change my exponent. So that's going to be to the second power. So I'm going to have x minus 5 squared. And at the bottom, I'm going to have 2 factorial. And 2 factorial is the same thing as 2. So that's my third term. Then the last one is when k is equal to 3. I'm going to get my value of 2 over 125. I'm going to get my binomial to be to the third power. So I'm going to have x minus 5 to the third power. At the bottom, I'm going to have k to be 3. So I'm going to have over 3 factorial, which is equal to 6. So I'm going to go ahead and put that as 6. So now we need to just simplify each of our terms and we'll be done. So we're going to find that our Taylor polynomial is going to be our first term of natural log of 5. Then our second one is going to be x minus 5 over 5. That's this term simplified. Now let's take a look at this one right here. So essentially I'm going to put my over 2 right here so we can see that this is going to simplify as negative x minus 5 squared over 50. Just multiplying top times top, bottom times bottom. And then for the last one, we can see that that's going to be plus, and I'm going to reduce my fractions here. So I'm going to find that my last term is going to be x minus 5 cubed over 375. And that completes this problem. For this problem, we need to use the power series operations to find the Taylor series for this given function. And we need to state it in sigma notation as well as writing out the first 3 terms. Well, one of the things that we need to notice is that we need to find the Taylor series for sine of x. We can either determine it by using our formula, or we can actually realize that this was actually given on the test. So I wrote out what sine of x is in the first 4 terms, as well as what the sigma notation is. So for our f of x, we're going to multiply x to the 5th to sine of x. So I'm going to write it as x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. So when I multiply it all out, I'm going to see that I'm going to get x to the 6th minus x to the 8th over 3 factorial plus x to the 10th over 5 factorial minus x to the 12th power over 7 factorial, etc. So this satisfies the first part that says to write out the first 3 terms. So the next one says to do sigma notation. Since we already have sine in sigma notation here, let's just use that in terms of our f of x. So f of x is equal to x to the 5th times my sigma notation. So I'm just going to abbreviate it like this. And we know that one of our properties says that if we have our exponent out here of x to the 5th, we could actually put it in here and multiply it with our terms. So when we do that, we're going to find that our sigma notation will actually have negative 1 to the k. And now I'm going to have x to the 5th times x to the 2x plus 1. That's going to give me x to the 2x plus 6 over 2k plus 1 factorial. And that's going to be our f of x. Let's check to see that this sigma notation is going to give us what we want. So when k is equal to 0, so that's where we're going to start. When k is equal to 0, I'm going to have, so I'm going to write it over here, I'm going to have negative 1 to the 0 power, which is 1. So that's positive. When I have 0 over here, I'm going to have x to the 6th power. And at the bottom, when I put 0 down here, I'm going to have 1 factorial, which is 1. So we can see we are getting our first term. When k is equal to 1, so when k is equal to 1, I'm going to put a 1 up here. I'm going to have negative 1. And then I'm going to put 1 right here where our x is. So that's going to be 2 plus 6, which is 8, so x to the 8th. And at the bottom, I'm going to put a 1 there, so I'm going to have 2 plus 1 is 3, 3 factorial. And we can see we're getting that next guy. So we can conclude that this is our sigma notation for f of x. And that ends this problem. For this problem, we need to show work to determine the first 4 terms of the binomial series. What we're going to do is we're going to use the binomial series, and then we're going to approximate the integral after we find the binomial series. So first thing is to remind ourselves, what is the binomial series? Notice we have 1 plus x to the p power, and it's going to be a sum from k is equal to 0 to n. And then we're going to have pk, our combination, and then we're going to have x to the k power. So one of the big things to remember is what is meant by this pk thing. So remind you that you're going to multiply times p, p minus 1, p minus 2, until you get one less than k. So if k is 5, you're going to have to do p, p minus 1, p minus 2, p minus 3, and p minus 4, because that's one less than 5. But then we're going to divide by the k factorial. So let's kind of make ours look similar to what we have. So instead of having 1 plus x, I have 9x. So I'm going to put that in like a parentheses or a bubble. So this is going to be a 9x. So when we do ours, we're going to make sure we have 9x to the k power. We know that our p is equal to 1/3, so I'm going to change my p here to 1/3. And we're going to go until we finish x to the third. So that kind of tells me that I'm going to just go to 3 right here. So we need to go find this coefficient for k is equal to 0, k is equal to 1, k is equal to 2, and k is equal to 3. So when k is equal to 0, I'm going to get 1/3, 0. By definition, that's equal to 1. If we find k is equal to 1, that's 1/3, 1, and by definition, that's equal to 1/3. Now, when we get to k is equal to 2, then it gets a little bit more interesting, because when we have 1/3, 2, then that means I got to multiply 1/3 times 1/3 minus 1, which is a negative 2/3, and then we need to divide by 2 factorial, which is 2. So we can see that this is going to become negative 2 ninths, negative 2 ninths divided by 2. Remember, that's the same thing as multiplying by 1/2. So we're going to have that equal to negative 1/9. When k is equal to 3, we're going to do 1/3, 3. We need 1/3. We need 1/3 minus 1. And we also need 1/3 minus 2. Because remember, we're doing the k minus 1. K is equal to 3, so we need to finish until we get to 2. And 1/3 minus 2 is a negative 5/3. And we're going to divide that by 3 factorial. So when we multiply the tops, I get a positive 10 over 27. And we're going to divide that by 6, because 3 factorial is 6. So remember, when we're dividing, it's the same thing as multiplying by 1 over 6. So I'm just going to simplify this. I'm going to divide by 2, so that's going to give me a 5. Divide by 2 down here, that's going to give me a 3. So I'm going to get 5 over 81. Alright, so we have found our coefficients. Now we need to go find our exponents for the x's. So here we go. We're going to find that our problem is going to be our first coefficient of 1, and then x to the 0 power, because k is equal to 0. The next one's going to be 1/3. Oops, I'm sorry. It should be 9x to the 0 power. Then I'm going to get my 9x to the 1 power. And we can see here that 9x to the 1 power is just 9x, but I get 1/3 of that. So we're going to see that that's going to equal to 3x. So for the k is equal to 2, my coefficient is going to be negative 1/9. That's this number. And then I'm going to have 9x to the squared power, because k is equal to 2. And we can see that that's going to be 81x squared. And I'm going to see that my 81 and my 9 will reduce to a negative. So let me make sure that this is a negative. So negative, when they reduces, it's going to give me 9x squared. So we can see that that's happening right here. Now we need to do that last term, and that's probably the one that gave most of us some issues. So for that last term, I'm going to get my coefficient of 5 over 81. I'm going to get my 9x, and I'm going to put that to the third power because k is equal to 3. So that's 9 times 9 times 9 x cubed. And I'm doing that because 81 will cancel out with 9 times 9. So this last one will be 5 times 9, which is 45 x cubed. So the number that we were looking for is actually a 45 right here. So this is our approximation using binary series. Now, even if we couldn't get to that, we should still be able to go find the integral. So what we want to do, since we already have a binomial representation for this, so what we want to do is find that the integral of 1 plus 9t to the 1/3 dt, we have this already estimated, so we're going to take the integral of 1 plus 3x minus 9x squared plus 45x cubed dt. Sorry, I guess all of these should be in t's, so let me do that. So we're going to take our integral of this. That's going to give me a t plus 3t squared over 2 minus 9t cubed over 3 plus 45t to the 4th over 4. And then we're going to evaluate it from 0 to x. So when I plug in my x, I'm going to get x plus 3x squared over 2. And then minus 3x cubed plus 45 over 4x to the 4th. And then we're going to plug in 0, and we're going to realize that all of these will be just 0. So this is our integral part. And that finishes that problem. The last problem that I want to discuss is using the Taylor series to evaluate the limit. So one of the big things that we're going to do is we're going to change e to the 3x into a Taylor series. So what we do know is e to the x is equal to this Taylor series, but we have 3x. So what we're going to have is e to the 3x is going to equal to 1 plus 3x plus 3x squared over 2 factorial plus 3x cubed over 3 factorial, and it keeps on going. So notice for us, we need to find the limit as x goes to 0, and instead of writing e to the 3x, I'm going to write this guy. So I'm going to have 1 plus 3x plus 3x squared over 2 factorial plus 3x cubed over 3 factorial, etc. And then I'm going to subtract 1 and subtract 3x and divide everybody by x squared. So notice that what we have is this minus 1 will cancel out this one. And this minus 3x will cancel out this 3x. And notice that now when we sit there and divide everybody by x squared, this one right here is going to actually cancel out. This one's going to actually be to the 1 power. The next one's going to probably be 3x squared over 4 factorial. So these will still have x's. So we've already divided everybody. So when we divided, this became a 1. We still have 3 squared right there. Over here, we said that this became a 1 here. This is still going to be 3 cubed. Over here, we're going to have x squared, and this is going to be to the 4th power. So we can still see they're squared or cubed or 4th power, but our x is going to be x to the 0, x to the 1, x squared, etc. So now let's go take the limit. When we take the limit, when x is equal to 0, well, this doesn't have an x in it, so that's going to be 9 over 2 factorial, which is 2. This is going to go to 0 because it has an x. This is going to go to 0 because it has an x. So here's our limit. And that concludes this video.